All right, we're on number 66 of the homework for section 11.5. So we have let me see. Q is the total number of units produced per day by M employees. So we have a production function. Number 66. So Q equals 200 times M minus M squared. So M is the number of employees. And this is a production function which basically relates the number of inputs into production, which in this case is only employees, and how much output that leads to. And then we have an inverse demand function where P equals negative 0.1 Q plus 70. And the problem wants us to find the marginal revenue product for the given value of M. So the marginal revenue product, so first of all, the revenue is price times quantity. So we have a revenue function, which is going to equal price times quantity, which equals negative 0.1 Q plus 70 times 200 M minus M squared over 20. The marginal revenue product is essentially the value of the output that an additional employee will generate. If you hire one more person, how much output will they generate, and what is the value of the output that they will generate? So we have a revenue here, and we basically want to figure out what is the derivative of this with respect to M, with respect to the number of laborers. So remember, Q here in the inverse demand function is a function of labor, right? So we're going to need to take, well, first of all, we have two expressions here, so we need to use the product rule. With this one here, we're going to need to use the chain rule also, because Q is not just, Q is a function of M. And so, well, we'll do it as I do it. So let's do it. So we'll call the whole function R, and we're looking for dr dm, the change in revenue with respect to the change in laborers. So let's use the product rule. We'll take the derivative of the first function. So it's going to be negative 0.1. So that's the derivative of the outside function. Remember, Q has an inside function as well. So that's the derivative of the outside function. Now we need the derivative of the inside function with respect to M, which is going to be 200 minus 2M. Okay, so now we've taken the derivative of this one. Now we just need to write the second equation because we're using the product rule, remember. Plus the first equation, negative 0.1 Q plus 70 times the derivative of the second equation with respect to labor, which again is 200 minus 2M. So now let's keep on trucking here. So 200 times 0.1 is 20, so negative 20 plus 0.2m times 200m minus m squared over 20 plus, we need to plug in this expression for q into this term here. So we have negative 0.1, so this is going to be a big bracket, times 200m minus m squared over 20 plus 70 times 200 minus 2m. Alright, so now we're gonna, I don't want to do all the math to combine terms and whatnot. We're evaluating this at, so the last part of the question says, in each case find the marginal revenue product for the given value of m. We're given a value m equals 40. So let's just plug that in and find the number. Well, plugging it in will get us to 36. I don't want to do all the math, so I'm just going to show you what the answer is. I won't give you a problem like this in the exam. It requires a lot of like math that just, I want you to learn the chain rule here. I don't want you to just get all frustrated doing really complex problems like this. So with this problem, the answer is 36. Hopefully you walk away with an understanding of what the marginal revenue product is, which is a concept that's important in economics, especially, well, certainly in microeconomics, and you'll encounter it again in intermediate microeconomics if you wind up taking that course. But as far as this problem goes, we're done. What was most important to understand was the application of the chain rule and the product rule.